I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll graph a couple of ellipses that are translated away from the origin. So how the equation for these are going to look, you're going to have x minus h squared in the numerator over some number that's being squared. So I'm going to start with the case that we have here where the denominator is a squared. This is going to have a horizontal major axis because the number underneath x squared is larger than underneath y squared. Plus y minus k squared over b squared equals 1. So h and k are the center for this ellipse. Those are the values that are being subtracted from x and y respectively in that squared term. Then once we plot that, we still move left and right and up and down by the correct amounts, draw the ellipse. We can find the distance for the foci using the same equation, but now because the center is not at 0, 0, it's going to be from that center. So like here, say the x-coordinate of the center is 4, and we find that, let's say that c ends up being 2. It's going to be different, but say it was 2, then it would be 4 plus 2 and 4 minus 2 in order to get to the foci. Anyway, let's try an example where its major axis is horizontal. In a minute, we'll do one that's vertical. The only real difference there is that a squared and b squared, the labels are different. All right, first, the center is 4, negative 1, because 4 is being subtracted from x, and negative 1 is being subtracted from y minus negative 1. One thing that my students in my intermediate algebra class would think about is, okay, what value of y makes that 0? What number plus 1 is 0? Negative 1. You could also set that expression equal to 0. Y plus 1 equals 0. Subtract 1, you get negative 1. That's your value of k. A is 5. And b is 3. So again, that's telling us how far left and right and how far up and down to move from that center. So the center, 4, negative 1. A is 5, so I'm going to move 5 to the right and 5 to the left from that point. B is 3, so I'm going to move up 3 and down 3. So graphing these basically turns into a counting exercise, right? Can you count 3 units up and down? Draw the oval, goes through those 4 points. There you have it. Now for the foci, we're going to use c equals the square root of a squared minus b squared. Here, that's c equals the square root of 25 minus 9. Or the square root of 16, so c is equal to 4. So we're going to move 4 units to the left and to the right because, again, the major axis is horizontal. So moving 4 units to the right, that is at the point 8, negative 1. 4 units to the left, that is at 0, negative 1. And those are the two foci for this ellipse. Just put some dots on the major axis. All right, let's try it again, but with the major axis being vertical. Everything we're basically going to do the same way. Okay, x squared over 4 plus y minus 3 squared over 36 equals 1. It's in the right form. The center is going to be 0, 3. When you have just a plain x term, h is 0. If you had just y squared, k would be 0. K equals 3. A squared equals 36, so a is 6. B squared equals 4, so b is 2. So we're going to go 2 to the left and right, 6 up and down. The number underneath the x squared tells you how far to move left or right. The number that's, sorry, I'm being attacked by my cats. The number that's under y tells you how far up or down to move. So let's start with the center, 0, 3. 2 left, to right. Up 6, down 6. So there we've got an ellipse that's pretty tight left to right, pretty expanded top to bottom. Let's draw that first. Something like that. The domain, I don't think I did that on the last one. The domain here, left to right, is -2 to 2. The range, bottom to top, let's see, it drops down to -3, but up to 9. Let's find the foci next. C equals the square root of a squared minus b squared. That's the square root of 36 minus 4, or the square root of 32. That's about 5.6-ish, maybe a little larger. Maybe 5.7. Let's see. Square root 32, 5.658, 5.7. So from the center, we're going to move up 5.7 and down 5.7. So the approximate locations of the foci, they're both at x equals 0, 3 plus 5.7 and 3 minus 5.7. Whoops. Zero, 8.7, and 0, -2.7. But if we wanted those exactly, it would be 0, 3 plus root 32 and 0, 3 minus root 32. But we could also simplify the square root of 32. That's 16 times 2, so we could get out a 4 from there. 0, 3 plus 4 root 2, 0, 3 minus 4 root 2. Those are the exact locations of those foci. Now, I did mention in the previous example, I did not find the domain and range. So let's go back and take care of that just to be complete. The domain, we look from left to right. So here, we're looking from -1 to 9. So the domain from -1 to +9. The range, we look from the bottom to the top. Starts at -4, goes up to a height of 2. Like that. All right, so there's how you graph ellipses that are not centered at the origin. We're going to translate them away from there. In the next video, we're going to talk about a concept called eccentricity.